So first of all, take you to a spring day a couple years ago when my son said, "Mom, can we go fly a kite?" And I said, "Absolutely, you bet, we can go fly a kite." So I took my camera along because it was a beautiful day. It was just the right amount of wind. And I filmed him flying his Spider-Man kite. So how many of you have never flown a kite before? Just a couple? Okay. I was one of those children who never got to fly a kite, so it was important to me to fly a kite with my children. So here he is flying the kite, and he's so proud of himself because he's not, he's got the string all the way out, he's keeping it up in the air, and he's not crashing it, and he's not getting it into the tree and all that fun stuff. So he's pretty excited. Okay? Well, then the question came from him, "Mom, how high is that kite?" And I said, "Well, I don't know, hon, but we can figure it out." Okay? We can figure it out by using something called trigonometry. Oops, I meant to go to the next slide. There we go. So this is the question that we're going to be able to answer by the end of the hour. Okay, and it doesn't have to be a kite. It can be a tower. It can be pretty much anything, right? But if you take a picture of a very high object and you know the angle of elevation, because you can take it to GeoGebra or print it out and measure it using a protractor. I knew that he had all 50 feet of that string out. So I knew that he, at the time, I measured him from where his hands were to the floor. He was 3 feet high. Then we can figure out how high the kite is. Okay, anybody have a prediction? 50 feet? What kind of triangle is this? A right triangle. The hypotenuse is 50 feet, and the hypotenuse of a triangle is always the longest side. So we know it's something under 50 feet, right? But without actually calculating it, we don't know for sure. So we'll know how to do that at the end of the hour. Okay? So that's our goal. So yesterday we talked about the tangent ratio, the TOA part of SOHCAHTOA. And the tangent was equal to what over what? Opposite over adjacent. The O stands for opposite, the A stands for adjacent. And which side, which leg is opposite angle A? And which one's adjacent? So 12 over 16 reduces to 3/4, 0.75. We did this yesterday. Okay? Today we get to talk about the other two pieces of this puzzle. One of them is the SO part, the sine. The sine of an angle, again, we're lazy. Tangent's pretty long, so it makes sense that we want to abbreviate that as TAN. But sine is also kind of long, and since we abbreviated tangent with 3 letters, we're going to abbreviate sine with 3 letters. And the sine of angle A, what do you predict that's going to be? Opposite over hypotenuse, absolutely. Okay, so opposite of A is 12, hypotenuse is 20. That reduces to 3/5, and as a decimal, that would be 0.6. Easy peasy, right? Okay, the hardest part is keeping them all straight. So what questions do you have about the sine of the angle? Okay, nothing more than a big table, right, of angles that all have the same, have special measures, right? Opposite over hypotenuse is this decimal for this angle, and this decimal for that angle, and a different decimal for another angle. Okay, just a ratio. Oops, 1 second. Okay. Then our next one is the CA part of SOHCAHTOA. And the CA, the C, stands for cosine. Again, another big word, so we like to abbreviate it COS, cosine of A. Okay? So when we look at cosine of A, what do you think the A and the H stand for? Adjacent and hypotenuse. Okay? So the cosine of an angle is the adjacent divided by the hypotenuse. Okay? We look at angle A and we say, guess what? The adjacent to this is 16. The hypotenuse is 20, right? And 16 divided by 20 reduces to 4/5, 0.8. 8/10. Make sense? Questions on this? All right, we're going kind of quickly, but I think you got the hang of it. Okay? So, on this particular problem, everybody find it on your paper? Right beneath the kite on your paper? Normally, they would not tell you that this was 56 degrees and that this was 34 degrees. Okay? They would ask you to tell me what's the sine of angle A, what's the sine of angle B, the cosine of A, and the cosine of B. Okay, but I have these up here to prove a point. We know from yesterday that if we take the sine of 56, we'll get a decimal, right? And the cosine of 34 will get a decimal because we have a cosine and a sine button just like we have a tangent button. So that would be a good check. But I have these numbers, these angles here for a purpose, okay? So let's start by talking about the sine of angle A. Here's our angle A. Just kind of put our finger on it, make a note of where we're at. And this time we want the sine of it instead of the tangent from yesterday. So it's helpful to write this over and over and over again. There's the so part. What do we want to find if we're trying to find the ratio of the sine? Opposite and hypotenuse, which is opposite the A. 2.7, which is the hypotenuse. The 4.9. So we're going to take 2.7 divided by 4.9. All right, so break out your calculator. Let's find this to two decimal places. What is 2.7 divided by 4.9? It's 0.55 as two decimal places. Okay, so that would be the answer for the sine of angle A. It reduces to 0.55 as two decimal places. There's a lot more to it, but 0.55 for now. Okay. Now let's find the sine of angle B. So again, put your finger on angle B and ask yourself which one is opposite and which one's the hypotenuse. 4 and 4.9. So when we take 4 divided by 4.9, what do we get? 0.82 if we're going to two decimal places. Okay? And if we plugged in the sine of 56, we should get 0.82. Okay, it's a good check on our calculator. Now, let's check on the cosine of A. Okay? The cosine is the ka part of SOHCAHTOA. So when we want the cosine of A, we put our finger on angle A, and we say that we're looking for the adjacent and hypotenuse. Which side is adjacent to A? The 4, which is the hypotenuse. 4.9. So we're going to take 4 and divide it by 4.9, and guess what? I have a feeling it's going to be 0.82. It was just a moment ago, wasn't it? Probably still in our calculator. Let's find the cosine of angle B. So cosine of angle B again says adjacent over hypotenuse. So which side is adjacent to angle B? 2.7, and the hypotenuse has been 4.9 this whole slide long, right? So 2.7 over 4.9, guess what? I bet that's going to be 0.55 again. Okay? Absolutely. And that's what we mean by sine and cosine. Okay? How are 34 and 56 related to each other? They add up to 90. And what's our definition or our term for angles that add up to 90 degrees? They're complementary. So when they're complementary, they add up to 90. That means that sine and cosine are complementary trig values, right? They're co-functions. Co for complementary. So that means that whatever you have for the sine of A is going to be the same thing as the cosine of 90 minus A. And whatever you have for the sine of B will be the same value as the cosine of 90 minus B. Okay? That makes sense. A lot of words. So if I told you that the sine of 30 degrees is 1/2, the cosine of what will also be 1/2? So if the sine is now, if the angle A is now 30, then the angle B would have to be 60, right? So the sine of 30 is the same thing as the cosine of 60. Okay? If I told you that the sine of 45 degrees is the square root of 2 over 2, what else would be the square root of 2 over 2? The cosine of 45 degrees. They're co-functions. Does that make sense? Okay, so you can save yourself some work. If you found the sine and cosine, or the sine of two angles, and you know the cosine of their opposite of their angles as well. You just flip them. Okay, so here's how it works. Okay, how do we write the cosine of 69 degrees in terms of the sine? Cosine of 69 degrees will be equal to what? Sine of how many degrees? Why is it 31? 21 degrees. Why is it 21? 21 and 69 add up to 90. So we get the sine of 21 is the same as the cosine of 69. Make sense? Okay. If I know the sine of 33 degrees, I also know the cosine of something. It has to be equal to the cosine of how many degrees? Okay, I know Jaden knows. Everybody understand why? How do we find that? Complementary. We find the complement. The complement to 33 is 57. They add up to 90 degrees. So the cosine of 57 will be the same as the sine of 33. That can save you a ton of time on your homework today. Okay, if that makes sense. All right, questions on this? Okay, next one. So, to calculate these trig ratios, yesterday we learned about our tan button, our tangent button, right? Today you get to work with your sine and your cosine button. Everybody find them on your calculator? So let's practice the tangent real quick. As long as your calculator is still in degree mode and you haven't changed it, I want you to find the tangent of 18. And what do we get? 0.32 to 2 decimal places. I think they asked us to, they didn't specify. Let's just do 2 decimal places for this slide. So 0.32, everybody get that? Okay. So now we did have 18 yesterday. I kind of left it on there. So now let's try the sine of 77. Everybody get 0.97? So 0.97. And then let's find the cosine of 84. 0.104, so 0.10 if we're going to 2 decimal places and being consistent. So 0.97 and 0.10. If you didn't get these numbers, make sure you flag me down so I can help you figure out your keystrokes on your calculator, because it's important you know how to run your calculator. Okay? Questions on these? Okay, next. So now that we know how to use our sine and our cosine buttons, then now we can figure out what are the values of x and y. So on this triangle, this first one that we have, it has an 18-degree angle. The minute I see an angle, I focus in on that, put my thumb on it or something along those lines, and I want to pay attention to that angle. So do you want to find x or y first? Okay, let's pick on y first. So if we want to find y, how is y related to this angle that we know? It's adjacent. And what other number do we know? The hypotenuse is 6.5. So if we have, we're looking for adjacent and we have hypotenuse, which part of SOHCAHTOA are we working with? The CA. Does everyone see why? Because the cosine is the adjacent divided by the hypotenuse. A for adjacent, H for hypotenuse. So the cosine of an angle, in this case we know the angle measure, is equal to the adjacent divided by the hypotenuse. Absolutely, we're currently dividing. We don't want to have that divided by 6.5 anymore. So what's the opposite of division? Multiply. We'll multiply by 6.5. So show me that for work, and then it's calculator work. Set it up. Tell me what you're doing in your calculator. Okay. Eric, do you have a calculator? So 6.5 times cosine of 18, 6.18. And they said to the nearest tenth, so this is going to round to what? 6.2. Make sense? Okay, so now we want to find the other leg. How is it related to our angle? It's opposite. Now we're trying to find the opposite. Now, if we made a mistake in finding our 6.2, we don't want to perpetuate that mistake by using it, right? So let's use the two parts that we already know. We know our angle and we know the hypotenuse. We're trying to find the opposite. So which part of our SOHCAHTOA are we using this time? So the opposite hypotenuse. So the sine of 18, angle always goes with the sine, cosine, or tangent, is the x over 6.5. So then just tell me, I'm taking 6.5 times both sides to make that go away. No more denominator. And so it's going to be won't be the same as y. Nope. But yes, just like before, we multiply 6.5 times the sine of 18 this time. And what do we get? 2.0. Does that make sense? You don't have to. I wouldn't count it wrong. Okay? We're used to dropping insignificant. It is a significant digit when we're saying to the tenths place, but we're used to dropping that. All right. So do you need to see another example? Okay. So we'll skip that one. We'll work our way to the next one. And this is saying, guess what? We want to be able to also find the exact values of the sine, cosine, and tangent, which means that we don't get to plug them into the calculator because that has to be rounded somewhere along the way, even if it's to 8 digits. So we want the perfect exact value that's pristine and not changed. Okay? So we look at angle A, and we notice if they're going to ask us for an exact value, it's going to have to be a 30, 60, 90, or a 45, 45, 90 triangle, or one of our special triangles. And here's our angle A. It's our 30-degree angle. So the sine of 30 degrees is going to be something over something. What number did they give us? 8 is the hypotenuse, okay? How do we get from the hypotenuse to the short leg? Divide by, because we want to make it smaller, divide by 2, and 8 divided by 2 is 4. Okay? Now that we have our short leg, how do we get to the long leg? Multiply it by the square root of 3. 4 square roots of 3. 3 angles. Multiply by the square root of 3 to get to your long leg. Okay, 3 different types of angles. Okay, so the sine of 30 is the so part, right? So, which is the opposite and which is the hypotenuse? 4 and 8. So we put down 4 divided by 8, and that reduces to 1/2. Okay? Jace, what's the cosine of angle A going to be? Like 4 square roots of 3 divided by the hypotenuse, 8. Very good. So the cosine of 30 is 4 square roots of 3 divided by 8, which reduces to square root of 3 over 2. 4/8 reduces to 1/2. 1/2 times the square root of 3. So far, so good? Okay. Josh, what's the tangent of angle A going to be? Four over which one's the adjacent to angle A? Which one's next to which of these? The 4 square roots of 3, right? So we're taking 4, the opposite, divided by the 4 square roots of 3, the adjacent. Okay? Those will cancel. And we don't like to have a radical in the bottom, so what do? Yep, multiply it by itself over itself, and we get a square root of 3 over 3. Now, remember that shortcut I showed you a little bit ago when we talked about co-functions, right? So the sine of B, the sine of 60, is the same thing as the cosine of 30, right? So we can save ourselves some time and just say this is the square root of 3 over 2. And the cosine of 60 is the same as the sine of 30, 1/2. So we saved ourselves a lot of work. Okay? And then finally, we need to find the tangent of B, the tangent of 60 degrees. So we go to our 60 degrees, put our thumb on it, right? And the tangent is the toe apart, right? So Eric, what's the tangent of 60 degrees going to be? What's the tangent of 60 degrees going to be? Which one's opposite 60? Which one's opposite 60? And which one is the adjacent to 60? So 4 square roots of 3 over 4 will reduce to plain old square root of 3. So when they're looking for exact values, that's what they're wanting to see. Radicals, not decimals. Make sense? All right, last problem. Back to our kite problem. So we have my son here flying his kite. He's holding the kite string 3 feet off the ground, All the kite string is out, all 50 feet, and we want to find the height of the kite. You want to call it H or X, or what would you like to use? X? All right, X is the height of the kite. Okay? So we know now how to solve this, because how is X related to this 33.9 degree angle? It's the opposite. And the other number that we have is the 50 feet. What is that? The hypotenuse. Which of the three trig functions deals with opposite and hypotenuse? The so. So we're going to use which of the three? S stands for sine. The sine of the angle, always angle goes with sine, is equal to what over what? X over 50. How do we solve that? Multiply by 50. So if we take 50 times the sine of 33.9, we'll figure out how high, what that length of that altitude is. What do we get? 27.9. So X is 27.9, but did we answer our final question? Because he was holding it 3 feet up to begin with, right? So when we add 3 to it, we get 30.9 feet. So I could answer him, that kite was 30.9 feet high when we took the picture. Now, not completely accurate. I don't know if you can see it on here or not, but there's some sag in the line. It goes about like this. So there's a little bit of error in our calculation because of gravity. Okay? All right, so assignments coming up. Please use your time wisely. Get your questions answered. I'm here before school, after school, advisement tomorrow to make sure you understand what you're doing.